Hi Meha, how are you?
I'm really good, Andre. Thank you so much.
Yeah, could you please tell a little bit about yourself?
So I am an Android developer at Tinder. I recently was promoted to be a staff Android at Tinder, so that has been nice. Uh, I'm here for almost 10 years, and I have worked in multiple different verticals, from chat to matches to recommendation systems, and currently working on lot of like user growth related domain. And I'm really like we just launched a feature called in real life, where Tinder also lets you connect people in real life. So I'm working on that feature and really excited. And thanks for having me, Andre, on this channel.
Yeah. Yeah, sure. Thank you for sharing that. So, by the way, our last video received a lot of positive feedback. So today we're doing part two with a completely different problem. So that would be really interesting to do. Are you ready to start?
Yes.
Cool. So today we're doing a mobile system design of a stock trading app. We need to design a simple, relatively simple application with 4 screens. The first screen is a portfolio screen where we can see total value of our portfolio, a list of stocks, and for every stock we need to show number of shares and a price and the price increase. And we need to update this information preferably in real time. Also, we can click on last orders and see orders list. So here for each order, we can see how many shares were purchased and at what price. The next screen is the stock information screen. And here we can see the company name, some information about the company like capitalization, things like that. And also important thing that we need to show a chart here with a stock price, a historical stock price. And you can see I added a small letters here, D, M, and Y, which stands for day, months, or a year. So we can change the period for which we're viewing the graph or chart. And we have 2 buttons here to buy and sell a stock. And those open a new screen where we can create a new order, for example, to purchase Apple stock for a certain price and certain quantity.
Yeah, this is really awesome. Let me gather some requirements. I think first thing I would like to know that this I see that we have this portfolio, right? And the portfolio will have some kind of list of holdings, I guess,
Mm.
Apple, AO. Um, how real time we want updates to happen.
Yeah, that's a good point. So we don't expect user to be trading on this screen, so updates can be less frequent here, maybe once a minute just to see the overview of our portfolio. But for our trading screen, we want to see them every second.
Yeah, that is good. Another question is about the order types. Do we want to like focus on the market orders or any advanced orders?
Let's focus just on market orders, but have option in the future to include also like limit orders or something like that. Just a field in our API to support extension in the future.
Uh-huh. Another thing is about any kind of push notifications we want to support in the system so that, even if the
Mm.
user is not online or if the app is in the background, it still receives information.
Yeah. Let's support push notifications, price updates for price updates.
Do we also want to support some kind of offline support for?
Yeah, let's do that. Let's make it simple. No trading in offline mode, of course. Yeah.
No trading on offline? Yes, that makes sense. Um, I think with this, I think I can start with, like maybe the high level design, and then we can come back if I'm missing something, or let me know if I'm missing something. But
Mhm.
I think the first thing is we want to do the portfolio. We want to view portfolio.
Yep.
Um, which will have basically all the value, holdings, cash holdings, all the information, along with an action to the last order. So we want to see view orders.
Yep.
Um, Another question is like how far can we go into the orders? Do you think like we can? So it will affect my pagination if we think like we will have.
Yeah, as far as possible. Yeah, so we definitely need to see all the orders.
Um, yeah, and I think for buy and order, we can also like place orders basically, and then the most important part is the real time stock updates.
Yep.
Do you think we should also add some kind of search functionality because user would like to search for specific. Um,
Yeah, that's a good point. Yeah, I don't have it in my mockup. Yeah, so let's assume we have a search somewhere in the portfolio screen where we can search for a new stock. Yeah.
Search in portfolio for the stocks, and we can get some real-time stock updates. Plus, we want to focus on also the chart, which can be month, and it can be defined in this way. Search for stocks in portfolio, and I believe we can also add search in for orders probably, but or we can add some kind of sorting, filtering.
For orders. Yep, yep.
Okay, I think this is. I'm thinking, did I miss anything? No, I think with this functional requirements, let me go to some non-functional requirements. One is definitely latency. We wanna. This is because it's a stock app. It's very live. We wanna like have as quick as possible. So 1 minute, around less than 1 minute for portfolio updates, and for stock updates, we wanna have like less than one, or around like yeah, less than 1 second is a good time frame. We also want it to be scalable. What is the um, uh, users?
Yeah, let's assume we have a 1 million daily active users and international audience.
Um, then I think we should also focus on the data reliability and freshness. So what it means is like we should be able to like like fetch the data if the user is on the app very quickly, and also store the data in for offline support. Also give some kind of push notifications. So we kind of maintain multiple different channels to keep the user updated about the app. Um, okay. And I think because it's a stock app, security is also very important.
Yeah, good point.
I think for do we I'm just thinking for outer scope, maybe login authentication. Do you think we should focus that part, or we can move it to outer scope?
Let's leave it out of scope. Yeah.
I think only with security, I'm thinking the most is like the user, if the user is inactive for around 5 minutes, we can, like let them re-authenticate using, the passkeys or biometrics.
Yeah, sounds good.
I think, let me know, Andre, if I missed something, but
Looks good. Looks good.
with that, let me move to the next part, which is the API design. And for the API design, I would say like we will go for the standard REST HTTPS API calls for fetching the portfolio. We will use some kind of JWT auth token for authentication. This calls, and for because this is like a live application where we need the updates are very important. I'm thinking we should go to WebSockets. which will give the bidirectional. It's a lightweight way to connect with a server, and that can stream the data to the clients, and even the client can request the data. So just for the latency part and more scalability, probably the WebSockets would be a great option.
Yeah, I have a question here. So the alternative option is SSE or server sent events. Obviously, most of the information will be coming from the backend to the client. So SSE kind of makes sense. So how do you think about it? Why choose WebSockets? Why SSE? How to choose between them? What do you think?
Yes, I think that's a great question. SSE works great as well in this kind of application because most of the time the communication is from the server to client. The only caveat is, like if if the user goes in the background and comes back again, then the whole thing needs to be set up again. WebSockets, it also needs to be set up again, but it's very lightweight compared to the SSE.
What about the latency? I think WebSockets would give us lower latency. Is that right?
Yes, WebSockets will give us lower latency, and also like some of the things the client can also like request to particular stocks, so there can be more bidirectional communication between the
Yeah.
client and the server that can be offloaded with WSS
Yeah.
WebSockets.
Makes sense. Yeah.
Um, so I think the one of the we should definitely do like a get request for portfolio.
Portfolio.
And I know like the modern apps are like even more efficient apps further break down the portfolio into like just getting the snapshots of like the cash holdings, and the entire holdings can be offloaded to another endpoint and you can merge all the data together. But for the simplicity of this, let's just go with portfolio. We will have some kind of models that will give me total cash holdings. Let me actually look at here. Let me just move this around. So cash, total cash can be double. We can have like um, total cash, total value. We can also have like a list of holdings, which can be list of holding for now. That will be my response to the request, will be a get request. Um, then we can have also like get v1, and the holding would be actually,
Yeah, let's define holding.
holding will be another class which will have symbol, um, which will be a string. It can also have some quantity about the stocks, which can be integer, percentage, profit loss. I think that's a good point. I think we can probably calculate some, um, we can do some calculations even on the client for the profit and loss, but we can only get like current market price. And we can also get, the market difference, market change, or the latest market price, the current market price, and um, percentage change.
Yeah, makes sense.
And then we can add if we need more, but for now, I'm thinking this might be good um, for that. Then the next, I think we will definitely need some kind of symbols. The stock details, we can call it stocks. So stocks, and then we can pass on symbol. So that can give me basically the details for the stocks, which can be, the same thing, symbol. This will have more information around symbols, company name. We can also have like total cash, market cap, P/E ratio, mm, etc. We can also Based on this, I think we can also have another endpoint, which is like get V1 stocks to get the charts information. So for the symbol, we can have some kind of um, history data, I think, which can we can query something like mm, number of data points, and also I'm thinking interval. So we can pass some interval, which is, either it can be,
Okay.
and we can also request like number of points, how many, what will be my sample size or my resolution size. So maybe some points which can be like 300 or something, and those and this is basically data points.
So let's talk about these points. So why do we need them? I guess just to clarify, our period is 1 year, but we can have a different data granularity, right? Or data density. And that's why we specify just a number. So that means we'll have 300 data points for 1 year. Yeah, that makes sense. Yeah, but
Yeah, I think it also for the zooming, let's say if I'm zooming into this chart and want to make it more interactive, then probably, like depending on my zoom scale, I can request for more granularity, like lesser points, but more data. So,
do you want to hard code this number on the client or not?
so I think we can defer to the backend to give us the data.
Okay. Yeah, makes sense. Makes sense.
Yeah, yeah, that's a good point. Yeah. And the data points will mainly include some kind of timestamp, um, price, volume of shares, so the users can basically see how it zooms in. And I think we can also like search endpoint, so we can have like a search the stocks, and we can have like some kind of query which can be like the stock, like that. And because it can be paginated, so we can maybe limit to 20. And I'm thinking we can use some kind of this can be more like a page offset pagination, because the number when you search it won't change too much.
Yeah, makes sense.
mm, I think that should complete my this. Then let's go to the order list. We will have orders. We can also have we can do a post order, that is um, supposed to be one orders, and that will have order ID. And I think when we do this request, we should also share the sorry, this one will not have order ID actually. We want to pass some kind of item potency key on the API call, which is more something like some kind of UID generation or some kind of timestamp that you can pass it to the backend, so that if you make the request again for the same order, it knows how to dedupe and only does not do the transactions again.
Yeah. Yeah, that's an important detail. I agree.
So get V1 orders. You can also do an update. Oh, I actually missed. The orders can be also paginated because we have a list of orders. So we can have some kind of pagination for this. And I think I want to go to cursor pagination here, because imagine I'm making orders, like multiple different orders, then you don't, you a page of pagination has like some kind of limitation. So I can use like cursor pagination here and limit to maybe 30 at the time. And maybe we can also have some kind of sorting parameter. So the backend can give us the sorted list, which can be based on time, quantity of shares, whatever we can support. We can also do some kind of delete, probably, if you don't wanna run orders.
Okay.
And I think we can also do some kind of patch or put if you want to update the orders.
Okay. Do you think we can update the order?
If we want to support it, that's a good point. I should have clarified first. Like if you want to change the number of quantity of stocks, or from, I think that is the main part. Like if you want to change the quantity of stocks.
Okay, yeah. Let's actually define order data model, if possible, please.
Yes. So there will be two things, like the order request will have some kind of timestamp. We can have some kind of quantity and the
Symbol?
symbol, yes.
Quantity.
And the order object real will be ID. So the backend, the server will create an ID. We can also have some kind of local ID stored as well, but that can be, the client can put in. It will have a timestamp, quantity, symbol, price, and other details. And I think for this, we will also need to define the order type, because we were saying like we will support from market, but it can extend to something else. So we can have some kind of enum that will,
Order type. Okay, yeah. Do we need to include it in our request?
yes, I think that's a good point. We can order type. We should, oh yeah,
Uh-huh.
that also reminds me another thing. We should also use whether the user is buying or selling. So some kind of
Yeah, absolutely. We forgot that. Uh-huh.
sell. So
Okay.
so we can say order side.
Mm-hmm.
Uh, I think that kind of, I think this should define my this, and let's define some of the WebSocket based APIs. So for WebSocket, we will have some kind of endpoint, which is like
Mm-hmm.
API slash trading.com, and then it can. So the way the WebSockets kind of, we will need some kind of subscribe, unsubscribe. Uh, there are also some kind of hard bit APIs, and then for the price ticker, or the price tick, we can say like quotes. And I'm imagining we will also need some kind of order. So you for the placing the order, we are using the post, but for receiving some of the updates. So maybe some kind of order updates can come as a part of the WebSockets. Um,
Yeah, so these are different messages, like WebSocket messages that client and backend would be exchanging. Could you please define, like specifically how they would look like JSON payloads that we'll use for them?
so, for example, for the subscribe, I think I have to look, but I think it will be pretty much. So there will be some kind of type, which is like subscribe, and then the response, uh, and subscribe, and then there will be some kind of channel, we can say, which will have some kind of a list of codes, probably a list of symbols,
Yeah.
Apple, Tesla, and then some kind of timestamp. Um, so it will have channel. Um, and then we can also have some kind of timestamp.
Okay, makes sense. So, for example, if we go to the stock screen, for example, for Apple, we need to subscribe to price updates, especially if we go to a day chart, intraday chart. So we subscribe to price updates for that stock, for example, for Apple. Yeah, that's good. So what will we receive as a response from the backend?
Yeah, so it will again send you like, hey, type subscribed. and then it will give you the codes, let's say, and that will have the the data, which will be more like, let's say, symbol is Apple, and it will give you the price change. Let's say it changed to certain value. It will also give you um, a quantity.
I don't think we need quantity here, so we just need a current market price and I guess a timestamp just to reference it, just to be sure that.
Yep, and some kind of timestamp. Um,
Mhm.
Thank you for helping. Um, yeah. So this is how it will keep giving us the data in real time, and whenever, so for the stock details, whenever we go to that particular page, it will keep pushing or getting it. It's like more like a push based mechanism. So the server will keep pushing this data to the client instead of client pulling and requesting.
Yeah, so we'll send this subscribe request only once, but this like price update event or message would be streamed like every second, let's say. Okay, yeah, makes sense. So what about the heartbeat? Why do we need a heartbeat at
So the
all?
heartbeat is very important because Android is governed by the life cycle. If the user is not on the if user goes in the background, it kind of wastes resources to push the data to the client in that way. So what the server does is it sends a message called ping, and with this ping message, it will have some kind of payload, um, some kind of timestamp. It's always kind of periodic check. The server checks on the client, and the client will return a reply called pong, which kind of says like, hey, I'm alive. It's just a timestamp check, or very simple, pretty much like a timestamp, like, hey, I'm there kind of thing. And so this is how the heartbeats, it's very important for the server to know that the client is connected, so that it doesn't waste resources pushing the data to the clients.
Okay, yeah, makes sense. Sounds good.
And I was because of the life cycle, so if the app goes in the background, it immediately unsubscribes. Again, you have to start with making connection to the WebSocket, and then the client sends the server the subscribe message, and then it goes from there. So it keeps going on like this.
Yeah, got it, got it.
Mhm. With that, let me go into the high level design. Let me know if any other questions.
No questions so far. I think we can move on to the next part, next stage.
And I think for the high level design, I'm thinking we will follow some kind of MVVM architecture, MVI. We will use Compose.
Yeah.
This is my app, and that is my backend, which is here. Let me start with the backend. So the backend is, we are saying that the backend is what my API gateways holds. My API gateways does kind of rate limiting, also does some kind of authentication checks, and we'll be supporting both like WebSockets and HTTP calls. We will also have some kind of I'm not seeing any images in this feature, but let's say there is something, then we will also have some kind of CDN.
So I have a question here. Can we actually use CDN for not images, but for caching historical prices, response, for example?
Yeah, I think you can use CDN for anything that you wanna cache. It's basically something that can gives or delivers the data fast to the users. So images are definitely like one of the contenders, but any kind of huge historical data, and they can go into megabytes, or even gigabytes of data. So CDN is a great way if the user wants to have very fine charts.
Yeah, sounds good. Sounds good.
And then we will also need some kind of FCM. or third party. Basically, FCM is a Fire-based cloud messaging provided by Google, but there are also third party that can support some kind of push notifications.
Interesting. Yeah.
So we can use them. Um, so I think this is going to be my backend, and then the backend will have its own services. It will have its connection to the brokers, stuff like that. Let me start with some kind of presentation layer, which will be, so we will have four screens here. So based on the UI, we will have like a portfolio screen.
Mm-hmm.
We will also have some kind of stock detail screen. And we will also have some kind of order screen. And then the placing the orders.
So we have order list and order ticket or order creation. Yeah, makes sense. Mm-hmm.
Order ticket, and this will be order list screen. We will have, for each of them, we will have some kind of stakeholder. So we will have a view model for each of them. The view model is basically a stakeholder, and that is directly connecting to the screen for
Yeah,
all the
makes sense.
updates. So this will be VM. And this will be at the UI layer, presentation layer, and we will use Jetpack Compose to define this screens. Um, and I'm thinking more in terms of like maybe we can use MVVM architecture. I kind of always like, if it's a very simple screen, MVVM is a great architecture to choose, or you can also like use MVI, which gives you, or some kind of UDF.
So let's make a choice. Let's actually make a choice. So what do you think would be the best here?
The best is a combination. I think for order ticket screen, I will go for MVVM. It's very simple. I don't have to do much. Order list screen, portfolio screen, where it can get really complex. The stock detail, I would go towards more like a MVI UDF architecture, which will give me more state determination.
Makes sense.
Um, then I think we will have some kind of DI. Um, we will use Hilt, but there are many different solutions out there. And then this will be more like a domain layer. This is where I will have use cases. So the great one of the practices, the VM, instead of directly going to the data layer or repository, we will have some kind of use case that can combine further the business logic and simplify the models for the UI. So for example, we will have some kind of observe portfolio use case that will, we can have something called refresh portfolio, so that can refresh every like every time a minute or something it's scheduled and it gets the data. The same thing for the screen, we will have observe screen, oops, sorry, observe stock details, and then we can also have data for observe charts. We can have like refresh.
Interesting. Why do you want to have two separate use cases, for example, for a portfolio? And similarly for charts, one is observe charts use case, another one refresh charts use case.
Yeah, I think so. Observe is more like a stream that is, like once it has processed the data, it's available for the UI to show. And refresh is more like when I'm pooling, when I want to make a request to the backend to like get me the data. So you need two different, it's like bi-directional. One is like I'm asking that API calls to happen, and the other is once it returns, it gets processed, and then it comes to the UI layer.
Interesting. So does it mean that we will initialize the action with one use case, but receive response from another one, right? So that would be an example of unidirectional data flow.
Yes.
Okay.
The same. Similarly, we will have something for observe, or we don't need to observe orders, maybe get orders. Actually, we should observe orders because we will be having updates.
Okay.
I think I forgot one more thing. This is good. We should add the status, order status
You mean in the API?
in the
Mm.
yeah, I think even with the API, because when I'm making placing an order, how would I know if it got succeeded, it failed on the back end, it, like, did the client make a request? I need some kind of status. And I think you also have it like status executed here.
Yeah.
But before I even reach to that stage, I might be like, because of the app can be killed anytime, we need to maintain some kind of status. Executed, maybe delivered. It can also be pending
Yeah.
and then failed probably. So I think this is like observe orders. So we should observe orders. We can also like place orders. So um, and I think one thing is also like sync any pending orders.
Why do we need that?
So let's say I have requested for like 5 different stocks, and then my network is flaky or my app got killed, something like that. Then there can be a periodic request. There can be a periodic check whether uh, can I what is my current status.
Mm.
Uh, I wouldn't know, and the source of truth would be in most of the cases we should believe on the server. Whatever the server tells us is the source of truth. But let's say I want to maybe execute some. The trading is not there, but yeah, there can be multiple scenarios where you want to sync with the backend and make sure like what is your current status, or you have some offline work that got, like that did not go through, then you can still make some requests.
Yeah, makes sense. I think the alternative here would be to have a orders repository that would be automatically syncing orders. So what do you think? How to choose between these two solutions? Either have a separate use case or just make repository do the work of syncing? Because we're not showing this syncing in the UI, do we?
No, we don't. Yeah, that's a good point. I think it is more of a responsibility of the repository to basically sync. Um, yeah, and then
Mm.
we can have some kind of work managers that can also like do some kind of periodic work.
Oh,
And
yeah.
again, yeah, yeah,
Okay.
I think you're right. Like maybe this use case doesn't make more sense here. And then we can have some kind of So we will have some repository, which is portfolio repository.
Mm-hmm.
Portfolio repository, we will have something for orders.
Yeah.
And I'm thinking we should also have something for the stocks because we maybe want to have some kind of offline support for the charts, some kind of historical or last available snapshot. Um, and then we can also have so this is my data layer.
Okay, so this is a data layer and it contains repositories for each data type. Yeah, makes sense.
Yeah. So this is my data layer and it will have repository here. And this one is actually my some kind of room DB. We can use room or any other way like SQL Bright, SQL White solutions to basically have some kind of SQL or database.
I can see that you have two like components. One is called portfolio DB and the other one is orders DB. Does it mean that you want to have two databases or these are just data sources that work with one database?
Um, yes, it's basically one database, but multiple different tables.
Okay, got it. Mm-hmm.
Um,
Stocks
and
team.
then we will have some kind of I'm also thinking we can have some kind of work managers here, which will do like a portfolio sync manager.
So yeah, let's do a deep dive into Work Manager. Let's talk about it. So why do we need Work Manager here?
Work managers are a great way if your app is in the background and let's say you frequently go and visit this app, it's important the app to give you the latest data available. Also, you might be traveling, your network can drop down. So the work manager, the way it optimizes it is it will, depending on what is the cadence, by default, it starts with 15 minutes. Every 15 minutes, if your app is in the background, it can kick off a task for you, fetch the portfolio snapshot, and update your local DB. And in this case, it will be portfolio DB. So when you come back, you don't have to like start with a huge diff, and you can start from a good snapshot as latest as maybe few minutes old data. So it's more like a pull based mechanism. So the way it works is it will, when let's say your app is in the background, it wakes up, the OS wakes up, takes a wake clock, make a request. It will go through your repository. It will combine the data, save it in your DB, and if you open the app at that time, then your view model will observe the changes.
Okay, so that would be really handy for prefetching. So if we want to keep our portfolio information updated, or for example, prefetch historical information for a certain stock that is in our portfolio, so that's likely to be viewed, we can do it via Work Manager in the background.
Yeah.
Yeah. Makes sense. Yeah, that's a great idea.
And you sometimes, I think it's important for some kind of one shot like order sync manager. We will
Mm-hmm.
also need some kind of order sync, and also sometimes the FCM. So let's say your order got executed, and it gives you a push notification that your order got executed, and it can also trigger a sync manager to fetch all the latest details from the backend.
Could you please add a few arrows to the diagram? So I'm specifically interested in how the repo and sync manager are connected. Is that right?
Yes. So imagine like this is like an Android component,
Hmm.
and imagine this is exactly like it's like a headless UI. So think of this as a parallel or at the same place where you will have your UI components, but it doesn't have any screen or any view to
Hmm.
interact, but it will still do the same thing as your view would do with some constraints, some kind of network constraints or some kind of constraint that you want to add so you don't end up using a lot of battery. Make sure like you're on Wi-Fi, your batteries connect, you're charging, all that stuff. So you
Yep.
can isolate to that part. And the way it would do is it will actually all these things will go to your repos. The same way here, it's not
Hmm.
necessarily the repository directly. It can also come via the same use case, let's say the refresh use case. And from the refresh use case, it will call the repo. The repo will basically make a request to the backend. Once the backend response comes back, it will uh, go, the repo will basically ask to load to the local DB. And because it's a flow room or SQL Bright is all flow-based system, it's easier for now the UI to observe the changes via the use case. So
Mm-hmm.
um, let me fix this. So
Yeah, so I'm thinking, do you want to have a component that would be responsible for making network requests?
yeah, I think I missed that. Let me add. So we need two services here. One is for the retrofit to make API
Mm.
HTTP calls, and other would be the WebSocket.
Oh, yeah, true. So We'll have two network clients, one for HTTP and another one for WebSockets. Yeah, that makes sense.
So it will be, we call it API layer, and we will have two components. One is for uh, basically HTTP service, that will be responsible for portfolio snapshots, stock details. For the first time, we will make HTTP calls, orders, everything will be executed here. And then there will be also some kind of WebSocket. That will be more like price ticker, order update. It can be subscribe, unsubscribe,
Okay, yeah, got it, got it.
and that will be making a call here, which will be a WSS API, and this is bidirectional. So there will be another, which will be from here.
And these arrows would be not from repository, but from a network client,
Yes.
like that.
Yep. So the repository will, so repository will first always check the DB. If it finds the data, it will flow, like it will observe the change. The UI will observe the changes, and at the same time, if there is no cache, it will go to the network, make a request, and then update the DB first, and then you can observe the changes in from the DB on the UI.
Yeah, sounds good. Do we have any components left, or is that it?
Um, I think I no, I think that this is all. This is the main component. And maybe for this, we will have some kind of CDN connected, not directly, but it will be the same way. It will come from the repo.
Okay, interesting. Let's do a data flow walkthrough. So, for example, for stock detail screen where we see the chart. By the way, how do you want to implement the chart on Android? Yeah, we didn't talk about it. Let's start actually with the chart UI and talk about data flow afterwards.
Yeah, I think there are many different ways you can do the chart UI. Um, because Compose makes it very simple, you can actually use some kind of point-based APIs and Canvas to basically draw the charts. That gives you more power for zooming, zoom out, and also like performance. In terms of performance, there's a huge gain if you use any APIs which are native. So I would prefer to build the charts if it is a simple chart, but if it is super complex, with, I don't know, like there are many different charts when it comes to trading, and I would in that case fall back maybe to some kind of JavaScript web-based interface that can build the charts for me on the web. It's easy to deploy on both the platforms, iOS, Android, and then you can render it. But there is always a trade-off between both the solutions.
Yeah, makes sense. Makes sense. Let's now talk about the data flow. I saw, yeah, this said earlier. So for the stock detail screen that contains the chart of, for example, for a certain stock, let's say we open intraday view. That means that we should see the historical data for the first part of the day, and also at the same time we should see new price updates, right? So how do you merge these like two data streams or data sources? So let's talk about that.
Uh, so, Andre, say again. So, from this screen, this is one chart where we will be updating the data, and the other one is this one, right? The prices.
Yeah, yeah. So because we have two data sources, for example, we get historical information using REST API, right? But for example, newer price updates we get through WebSockets. That means that we need to merge this information, and also we can actually update the graph as well. So we can show new price updates in the chart so we can update the chart to show the latest price.
Yes, I think you are. Yes, I think that is one of the nuances we have when we have different ways of getting data from. Um, so you always start with something which is like a snapshot when you first like cold start the app. So even for the stock details, you make an HTTP request call, you get the data. So if let me see if I can this. So let okay, I think I can use this diagram. So when you first cold start, you go to the particular stock details screen, you make an HTTP call via the use case. So let's say you start with this, the data flow from here. You go from here. You from this, it will go to this the stocks, not stocks like get requests, and then it will go to the repository. So repository will make an API call on the backend, get the latest data, and then at the same time you will have the chart that will also. So the way, so let's say this is the first time you are opening the app, and now you have the data available for the stocks. And the way we designed our API is it will give you only the stock related information, like the fundamental information in one, and then the stock, the chart related information in another API. So you will basically not try to load at the same time, but you can show some kind of shimmer animation until your second API returns and updates the chart. So with Compose, you can have like different states defined, and one state will be responsible for updating the other data. Then let's say now you have subsequent changes coming from the WebSocket stream. So you want to also stream those changes to your main screen and as well as the chart. So the way it does is again, the WebSockets are coming in, the stream is coming in, the data. The repository will continue to save them in the DB as the new streams come because of the timestamp. It has the latest data from from a particular snapshot and up, and the diffs will then be sent to the UI.
Yeah, makes sense. So yeah, so that means that we'll merge the information in the repo and just return one single data stream to the UI for simplicity, for yeah, for our data updates.
Yeah, it will keep merging on into the repo. So the merge, so all the merge happens at the repo layer, abstracting away all those complications at the UI layer. UI will only listen to the single stream of flow emitted from the database.
Okay, yeah, sounds good. Do you want to talk about quickly about the life cycle?
I think there are three main things like the cold start. So you need to rely on the snapshot and then the streaming while the user is in the foreground. The second is when the user goes in the background, what happens? So you stop all the polling mechanisms and delegate something to the work managers if you want to do the periodic syncs. And it's also like a poll based mechanism, but it's periodic. It's governed by the OS. It also
So we close, sorry for interrupting. So we close WebSocket connection when we go background. Yeah.
Yes.
Oh, yeah.
We close the WebSocket connection. We close any kind of streaming or polling, and then we delegate to WebSockets. WebSockets, sorry, the work managers, and the work managers are responsible. Then they work with the dose modes and app standby buckets. So that kind of also helps the battery. You know, like the stock exchange is pretty much like streaming the live updates every second, or even less than a second. So you don't want to consume battery too much. So that gives you more smarter way to handle your updates. And when the app comes back to background, come from background to foreground, then you again resubscribe. You start with the HTTP request. So you again get the snapshot, and then you establish your WebSocket connections and start streaming your stock updates.
Okay, yeah, I think we can wrap up. Thank you for the mock interview. Give me a minute to clean up my feedback. All right, so please see my feedback. The decision is higher. You did really well. Let's break it down into different components. For problem navigation, you were driving the discussion, That was great. You asked questions. You broke down requirements into functional, non-functional, out of scope. That was good. The timing was also pretty good. You optimized small things, didn't spend too much time in API and data models. We had enough time to cover the problem. So for solution design, most important, you achieved a working solution. That was great. I really liked the part about state management and state restoration and how to handle background and foreground work. So you handled it really good. Also, you did really well with API design and WebSockets in particular. I really like that we broke WebSocket events down, specifically even like the ping pong and reconnections, all the small details. Also, you did well with app architecture, and I like that you introduced Work Manager for prefetching information and background works. That was great. The only few comments that can be improved. Maybe we could have spent some time discussing handling scalability for some edge cases and interesting situations. For example, what if a user subscribes to 1,000 stocks? And we have a lot of users like that. And another one, yeah, we didn't have time to cover security, but yeah, this is quite a big problem. It's difficult to cover all the small aspects. Yeah, we had other great deep dives. So for technical proficiency, also, you know common frameworks, APIs, you suggested trade-offs and identified alternative solutions. That was great. And for technical communication, again, you did really well. You responded well to my questions and feedback and explained your ideas clearly and logically. Yeah, so thanks again.
Thank you, Andre. Thank you for giving the chance. I really enjoyed it. It is one of the complex system design problems. And yeah, and it kind of covers a lot in terms of decisions and, like which architecture to choose.
Yeah, true. All right, thanks for doing this. Yeah, see you.
See you.